Alright, so 5.4, November 2nd. November already. Let's get started with these warm-ups. So we've already covered some of this stuff. You ought to be able to, again, pause. Always try to do the warm-up before if you can. Always try to pause when you think you can finish a problem. So everybody ought to be able to do the first part of this, labeling these points and plotting these points. So negative 1 is over here. So that's point A. And then -1, -7 is down here. That's point B. And then 5, -1, that's point C. So we can connect those. It's always nice when you can use a straight edge. It makes the lines look better and clearer. All right. Give the name and give the coordinates of the point of concurrency of the altitudes. So altitudes are from a vertex perpendicular to the opposite side. So our altitude here is a little bit awkward, but it's actually going to be this side. And it's going to be this side. So those are going to intersect at -1, -1 for the altitudes. Now, you need to think of the name for that, and you can use Pamasico, or altitudes is a vowel, and so the two that start with vowels, also their points of concurrency start with vowels. So it's O, so it's orthocenter. All right. Now we could draw the third altitude on here. The slope of this line is 1, so perpendicular to that would be -1. So that would be the third altitude. We didn't really need the third altitude because we had the other two. So those are the three altitudes. Remember, one more time, an altitude goes from a vertex perpendicular to the opposite side. Now, we may have to extend a side in order to draw an altitude sometimes, but not in a right triangle. All right, so now we're going to do the perpendicular bisectors. So perpendicular starts with P, so that's a consonant, so this would be a consonant. All right, we can plot it first. So 3, 0, D, so over here, E is 3, -6, and F is -1, -6. All right, so there we go. So perpendicular bisectors, that's because we have a horizontal and a vertical side here, those are pretty nice. So just straight up and down for this one, and straight across for this one. So perpendicular bisector, bisector, halfway. So we've got those. That's the coordinate right there. So that's 1, -3. And we could draw a circle around there. So that's the circumcenter. Perpendicular bisector starts with a consonant. Circumcenter starts with a consonant. So perpendicular bisector, we could also do this. The third one here, we don't need it, but again, we could do it. So this is 3/2, so that would be -2/3. Bisector, that's going to be right there. So 2/3 come down here, and to make it perpendicular, it would be perpendicular to that side. Alright, so that's the warm-up. Let's look at today's lesson. So mid-segment of a triangle. Mid-segment is a segment that connects the midpoints of two sides. So this is a mid-segment of this triangle. This is a mid-segment of this triangle because it connects the midpoints of the opposite sides. You can't see that. It's behind there. Okay. So the Midsegment Theorem says that the segment connecting the midpoints of two sides is parallel to the third side and half as long. Okay, so it says show that midsegment PQ is parallel to DE and half as long. So let's do parallel first. So let's do the slope of DE. Slope of segment DE. So the slope of segment DE is going to be the change in y over the change in x. So the y is 2 minus 0, 2 minus 0, and then 5 minus 3. So 5 minus 3. So that's going to be 2 over 2, which is 1. Okay? And now let's do the slope of PQ. Slope of segment PQ. So always check the scale. It's going by ones here. Even though they had all the points labeled. Well, they don't have P and Q labeled actually. So this is going to be 2, 3. And this is going to be 1, 2. So that's going to be 3 minus 2, y minus y over x minus x, 1 over 1, which is 1. So equal slopes mean that the lines are parallel, or the line segments are parallel. Okay. Now if we find the length of DE, so with no line segment, just the letters, that means the length. So that's going to be x minus x squared plus y minus y squared. So that's going to be 2 squared, which is 4, and 2 squared, which is 4. So that's going to be root 8. Which is, you can see here, 4 times 2. So you have root 4 times root 2, which is 2 root 2. Now if we do the distance from P to Q, that's going to be x minus x, so 2 minus 1 squared plus 3 minus 2 squared. So that's going to be 1 plus 1, which is root 2. So 2 times PQ equals DE, or PQ equals half of DE. Alright, so we showed both of those things to be true. So we just verified. And we didn't prove it just because it just happened once. That's not a proof. A proof's a little bit more complicated than that. But alright, so let's move on. This is highlighted as a test question. It tells us that those are mid-segments. So JK, now they didn't need to tell us that because I can see that these two segments are equal and these two segments are equal, so that means those are midpoints. So we should be able to tell it just from the picture. We don't need to be told. Alright, so it says find JK. So JK is the midsegment that matches up with this side. It's parallel to this side and it's half as long. So JK should be 5. All right. And it says to find AB. Okay, so AB, that's going to go with this. And just like JK went with AC. Okay, so this is the normal situation. You're either gonna take half if you're trying to find the mid-segment, or if you have the mid-segment, you're gonna double it. So that's gonna be 2 times 6. That's gonna be 12. So that seems pretty straightforward. All right, write a congruent statement. All right, well, there's, if we look at this, these two sides are congruent. If you look at this, that matches up. Those are congruent. If you look at these, right, if this is half of that, then, and there's 2 of those, this will be equal to those. So now we can see triangle, and the best letter, we're focused on these 2 triangles right here. So the best letter that's involved in these 2 blue triangles is B. And then in that H-I-J-K, so it'd be B-J-K is going to be congruent to triangle. Now B is in between the 2 and the 3. So the 2 and the 3 here is K. So that second triangle, the parts have to match up. J is in between the 3 and the 1, so that would be L. And so we could mark that on there, that, and that. And then finally, that's going to be C, and we could go a step further and say that that's side-side-side congruence. Okay, so on the first triangle, we do want to still remember alphabetical order. Okay? All right, so let's continue. So we brought this up a couple times. When you look at a graph, it's asking for the coordinates of Q and R. Now Q, they're both off a little bit, so maybe you're thinking 1.5 and 2, something like that, but we can't go by that because we don't have the scale. Okay? So you want to be careful not to jump to conclusions about graphs when we can't see the whole thing. All right. So what are the coordinates of Q and R? Well, Q, because of these 2 markings on here, I know that Q is the midpoint of segment MN. All right. So if the midpoint formula is the average of the x coordinates and the average of the y coordinates. So a plus 0 divided by 2 and b plus 0 divided by 2. So those are the coordinates of Q. And then we were asked to find the coordinates of R. So that's going to be a plus, again, still, midpoint, average. And I know it's a midpoint because of these markings on here. The average of the x's, so a plus c divided by 2. And the y coordinates, b plus 0 divided by 2. I don't want to write down b plus 0. You can if you want to, but okay. So y is segment QR parallel to segment MP because they have the same slope. We hopefully can tell the slope there, the change in y is 0, so it's going to be 0 divided by the x's, so same slope, 0, both horizontal. Okay. What is the length of MP? Length of the distance. All right, so on a number line, if it's straight across, you can just take the absolute value of the coordinate, and you get the difference of the coordinates. So if you think about if we did that in reverse, if we did 0 minus c, we took the absolute value of that still would be c. So the length of MP is c. Now QR is up here, and that's also kind of like on a number line because it's horizontal. So we could take a plus c over 2 minus a over 2 for QR. So they have a common denominator. So that would give us a plus c minus a over 2. We can put it all together. And the a's would cancel out. And we would just get c over 2. So QR is c over 2, or 1/2 c. So again, it's just kind of verifying the mid-segment theorem, showing us what's going on there. Okay, so another test type question here. Those are all mid-segments. Find the perimeter of x, y, z, so the big triangle. So if they're mid-segments, then we want to realize that the side is double the mid-segment. So this side will be 10, this side will be 14, this side will be 12. Or you can think about it this way, they're all being doubled, so it would be 5 plus 6 plus 7 times 2. So that would be 2 times 18, which would be 36. Sometimes there'll be units on there, so we might want to put units here just to let us know that it could be that. Now, we also, like I said, we could have doubled all the sides, so we could have said 2 times 5 is 10, and 2 times 6 is 12, and 2 times 7 is 14. So we could have done that, 2, 12, 14. We could have added those all together, and it should be okay. So alright, so we want to get these points plotted on here, and sometimes I don't like labeling them because I don't know where the other stuff's going to go, but so sometimes I might want to wait on that a little bit. But we'll see here. Alright. So it says those are the midpoints of the side of a triangle. What are the vertices? What are the coordinates of the vertices? So if you think about that, that's the little triangle inside of the bigger triangle. That's what this is. So if we want to get the vertices of the triangle, what we can do is think about it. So if we have this and we have this, then we can put a side through here that is parallel to this and twice as big. So I want to put a side through V that is parallel to this and twice as big. So if you look at this, this goes down 2 to the right 2. So if I go down 2 to the right 2, that would give me this point. If I go up 2 to the left 2, that gives me that point. So that has a slope of -1. This has a slope of -1. So they're parallel. And because I went down 2 over 2, then it's going to be twice as long. Okay, so we already have 2 coordinates right there. Now here we could do the same thing. So we can see this goes down 1 to the left 3, down 1 to the left 3, and there will be our third point right there. We could connect those if we want to. So I'm going to call this A, B, C, just to give them. So that's going to be 0, 2, and B is going to be 1, 2, 3, 4, 5, 6, 4, and C is going to be 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, a couple of review things here. So we want to review all of the segments inside of a triangle. Okay. And we want to fill those out, and we can try and go in order. So the very first one we learned about was perpendicular bisectors, and then we learned about angle bisectors, and then we learned about medians. So it would have been good for you to pause this, and I mean, hopefully you have all this memorized. So pause it and try to fill it out, draw them on the picture, and then come back. Okay, and the last one was altitudes. So then we can try to go in and fill in these things. So PC, or we could go down and think Pamasico. Oops, I was trying to color code that. Pamasico. That was O. So Pamasico, another way to help, just trying to find different ways to help you remember it. So another thing I said, remember these are both consonants, these are both consonants, those are both vowels, those are both vowels. So that is the circumcenter. Okay, so perpendicular bisectors. So it needs to be at a right angle, so these both perpendicular, but it needs to bisect. So if you look at it, it looks like that bisects that. So that would be, I'm going to write that over here. So that would be the perpendicular bisector. Okay. So I could highlight that too, maybe. All right. Angle bisector. So the angle bisector needs to cut an angle in half. Well, looks like that one there. And the angle bisectors, vowel, their point of concurrency is the incenter. Okay, so angle bisector. Okay, medians, MC, median, centroid, and the median connects the midpoint of a side. to an angle. Midpoint. So the midpoint was right here, because the perpendicular bisector goes through the midpoint also. And it connects an angle to the midpoint of the opposite side. Okay, so that's our median. Let's squeeze that in there. Yep. Median. Alright, so that leaves us with our altitude. Altitudes are also perpendicular from a vertex to the opposite side, or the opposite side extended. Sometimes we have to do that. So that's the orthocenter. I think we had one of those at the beginning of the notes as well. And that's an altitude. So reviewing some vocabulary and what we have there. And then we have some solving. So let's start with this one. So there's two main ways you can do this. You can extract the square root or you can factor. Okay? So extracting the square root, we would add 144 to both sides, and then we would square root both sides. Get the absolute value of x equals 12, and then this is something we've been trying to emphasize to you this year, that would be plus or minus 12. And hopefully everybody understands that means that the answer is negative 12 and 12. There's two answers. We just write that as a shortcut. Now, the other way you could have solved, another way you could have solved that was with factoring. You could have factored that as the difference of two squares. So you could have said x plus 12, x minus 12, and since it's an equation, has an equal sign, that means we want answers. So those are our answers. Now, on part B, people have a tendency to want to square that. That's going to make this much more work than we don't need to do that much work. So what we can do instead is subtract 5 from both sides, and that would give us 60. Okay. Now we can take the square root of both sides. There's actually a procedure called completing the square where we do things like that on purpose to get it to this form, so we can take the square root of both sides. So same thing over here. When we square root something that's squared, we get the absolute value. Now this side's going to be 4 and 15. A quarter hour, 1/4 of an hour, quarter hour, quarter past, 2 root 15. So now when we take off that absolute value, we're going to get plus or minus. And then we're going to add 6 to both sides. All right. Now again, just to reiterate, don't forget that means the pot that and that. It's two answers. Okay? All right. Now, one mistake that some students make here is they add 4 to x to both sides and then they divide by x. When you do that, you are losing an answer. So things that are squared usually have two answers. So what we want to do here actually is factor a GCF, factor that out. So our two solutions are going to be 0 and 4. Zero product property. If you multiply two things together and the answer is 0, then one of those things had to be 0. So either this had to be 0 or this has to be 0. If this is 0, then x equals 4. Okay? And again, these review questions, you should be able to pause and do those yourself. Okay, a little Halloween humor though. I think we might have missed it. Might have because of pushing back 2 weeks. Normally this cartoon would have been before Halloween. But his mom says, "What's this?" And he says, "My Halloween costume wish list. They're the scariest costumes I could think of. Vampire, zombie, math teacher." Yeah, long division gives me the creeps. Anyway, have a good day, everybody. It's about that time.